So today we will discuss the question number 2 of sheet number 6. Okay. The first question of the sheet is about the traces at different positions of a plane, and this is the question number 2 of sheet number 6, where we have to draw the projections of a regular hexagon of 25 mm side, having one of its sides is in the HP and inclined at 60 degree to the VP, and its surface making an angle 45 degree with the HP. Now this question we had earlier solved in our in our sheet number 5 with question number 4. So this is the solution of that sheet of that question. So the same question now we have to solve with the help of the auxiliary plane method. Okay, the first step will remain the same as the previous method. So we will draw the true shape of the regular hexagon, which is having a side of 25 mm, like this. So the first step will remain same as it is. Okay, so I am just copying the first step for the solution of the question. So this is the first step. This is the first step. Okay, so we have drawn the true shape of the hexagon and its front view and its front view. Okay, so this is the shape. This is the first step. Okay, so this is the, for example, the xy line. Yes. Now, in order to solve this question with the help of the auxiliary plane method, we will make use of two planes. The first one will be the auxiliary inclined plane, AIP, and the another one will be the auxiliary vertical plane, AVP. To make this plane, we will use the inclination with HP, and to make this plane, we will use the inclination given with respect to the VP. This we have to remember. And okay, this we have to remember. So let us now use a plane, auxiliary inclined plane. So the inclination with HP is given to us as the 45 degree. So we will draw a auxiliary inclined plane at an angle 45 degree. At an angle 45 degree. So this is the protector. This is the front projection. Since this inclination of 45 degree will be seen in the VP, so this is the point of 45 degree. This is the representation of the 45 degree. So we will make the plane. We will make the plane. We will make the plane. So this is the plane. This is the plane. Okay. So this is the plane, and this plane is called as the auxiliary inclined plane. Auxiliary inclined plane. In the next step, we will draw the projectors, which will be at 90 degree to this plane from these reference points. So from here, this is 90 degree. This all will be done with the help of the 2H pencil. This is 90 degree. This is 90 degree. Okay, now we will project these points on these projectors. So for that, we will use the compass to measure the distances. So this C to measure the distances. Now to measure the distances for this plane, we will use the distances from the top view. For example, this point B is at a distance of this much from the reference XY. This C is at a distance of this much from the reference. So the other ones. So like the other ones. So I will put the one end of the compass here, another end here. So this will be the distance C. So I will move the compass, will mark here. This will be the distance C, and this will be the distance F distance. I hope it is clear. Similarly, for the distance B, we will measure it from here. So this will be the distance B. We will rotate it. So this will be the point B, and for the point F, we'll keep it here and we'll mark here. So this will be the point F. Okay, similarly for the A and D, we will use this compass. We will put one end of it here, another end is here. Okay, so this is the distance, and for the D, this is the distance. So you will use the compass to mark all these points from the auxiliary inclined plane. Okay, and similarly for the A, so let us, here it is the distance of point A. Okay, so This is the closer one is point B, so this is point B, this is point C, this is point A, this is point D, this is the closer one is F, this is E. Now we will join these points. Now we will join these points. So from A to B, B to C, C to D, D to E, E to F, and F to A. So this is our auxiliary top view. Now to make the auxiliary front view, now to make the auxiliary front view, we will take the auxiliary vertical plane, and angle with the VP is given to us as the 60 degree. So we will make an auxiliary vertical plane at an angle of 60 degree with respect to one of its side, which is BC, as given in the question. As given in the question. Okay. So first of all, we will measure the angle. We will measure the angle. So from this side BC, this is the angle 60 degree. Yes, this is the 60 degree point. So I will join it from here. So this is the plane. So this is the plane. Yes. So this is the plane. This is the plane. Yes. Let me raise the extra projectors from here. Yes. This is point D. Okay. And this is the auxiliary vertical plane. And this is the auxiliary vertical plane, which is at an angle of 60 degree with respect to this side BC. Now from these points I will draw the projectors. I will draw the projectors which will be at 90 degree to this plane. 90 degree to this plane. So this is the projector for B. This is the projector for C, for D, for E. This step is very important. F, yes, A, yes. Okay, now to draw the auxiliary front view, we will measure the distances from the top view. From here, we will measure these distances. We will measure these distances from this point to this one, and this distance. Okay, so the distance of the point C and B from this plane is 0. So this distance is 0. Yes. So now to measure the distances for the auxiliary front view, we will measure the distances of the top view from this plane. So the distance of point CB from this plane is 0. The distance of point D dash and A dash from this plane is this much. This we will measure, and similarly for the E and F, this we will measure. So this is the projector of C. This is the projector of C. So this will be the point. So this will be the point. Okay, this will be the point C dash. Similarly, this is the projector. So this will be the point B dash, since its distance is 0 from the plane. The distance of A and E is this much. Distance of A and D is this much. So we will measure it with the help of the compass. We will measure it, and then we will put one tip of the compass here for the D. So this is the projector for the D, this one. So we will keep it here, and then we will make an arc. We will make an arc to get the point. Since this compass has a larger range and this distance is very less, so I am making the location on the projector of D. So this is the projector of D. Let this is the point D dash. Similarly for the A, this is the projector of A. So this is the distance. This is the distance A dash. Okay, then for the E and F, we can measure it with the help of this compass now. So one tip here, then we will rotate it. So this is the distance. This is the distance. So we will keep it on the projector of E. So this is the position. We will rotate it to get the mark. Yes. Okay. So this is the point E dash. This is the point E dash, and similarly For the F, we will use the projector F. This is the projector F. We will shift this compass from there to here, and we'll make an arc. And we'll make an arc to get the location of point F dash. So this is the point F dash. Now we will join these points. We will join these points. So we have this one as the A dash. So A to B, B to C, C to D dash, A dash to B dash, B dash to C dash, C dash to D dash, D dash to E dash, E dash to F dash, then F dash to D dash. So let me erase the extra projectors for the clarity. Yes. Yes. So this is the view. This is the final auxiliary front view. Yes. So this is the final auxiliary front view. A, F, V. Okay. So this is how we can solve this question. So with the help of this method, we can save time as compared to the previous method. Here we need to first draw this one, then to take the inclination with respect to one of the planes, then for the another plane. So this is completed into 3 steps. And in this method, the auxiliary plane method, we have to just repeat the step number 1. Then from this, we can directly get the top view, auxiliary top view, and the auxiliary front view.